Good afternoon, good evening, good morning, wherever you are in the world, and welcome to our sixth and final series in our Back to Basics series on emerging technologies and future developments in fires and firefighting. My name is Michelle Pitkin, and I'm the Vice Chair of the Fire Risk Management Group. And it's my pleasure to introduce to you Neil Vincer, our Chair of the Fire Risk Management Group, and Ian Scott, Committee Member, who will be leading you through today's webinar. If you have any questions, please put them into the Q&A chat function at the bottom of your screen. We will try and answer as many of those as possible at the end of today's webinar. The webinar will also be recorded and will be available on our Fire Risk Management Group page as well as the IOSH YouTube page. It's now my pleasure to hand over to you to Ian Scott for today's webinar.
So number 6 in our series. This is the last one for the moment. It's about utilising new and emerging technologies to combat fire. What a very grand title it has as well. First of all, I'd like to say, if you've been with us throughout the whole journey, then that's fantastic. It's great to see you back. And thank you very much indeed for taking the time again to join us today. My name is Ian Scott. I'm a volunteer member, as Michelle says, the Fire Risk Management Group. And I'm very pleased to be able to talk to you about what I think, and it shows there against my name, a little light bulb moment, what I think are the present and future developments in fire safety. Many of these, of course, are in the UK, but an awful lot of them are worldwide as well. So a definition. Present and future developments. It's a hybrid of present day real time and, as I say, light bulb moments. It's a bit of imagination, really, based on what we can see and what we read about and such like. With respect to fire safety, we'll stress that particular point. You will see and hear a lot of maybe commercial business related stuff, a lot of developments in terms of science, technology and engineering, but principally we're focusing here on the effects that we have in terms of fire safety. So it occurred to me when I started this, how do you actually put something like this together? And I sat down and I thought of various issues that you could base developments on: people, professional impact, and so on. As it says on the list of 9 topics, 9 subject areas on the left-hand side of the slide. I then thought, how could I represent these and all the various component parts in them? Draw a sketch, do a diagram, plot it out, or just write it down. But one technique which came to mind, and I'm sure many of you other safety professionals listening to this morning would be familiar with, are mind maps. So where you start with a central idea and you think about things that could be aspect and impact around that and how they all come together. So on the right-hand side there is a classical sort of mind map template of things that you want to do. So you're ready for this? Do you want to see what the mind map looks like for this particular topic? There we go. It looks complicated at the beginning, but it's really quite straightforward and logical, I hope. And starting at the 12 o'clock position with number 1, people, and then running around professional impact, emerging technologies, new products, and so on, all the way around the central theme of present and future development of fire safety, and ending up there with fire investigation. Let's start with people. As it says at the top of the screen, people are influencers, and certainly so in fire safety. And some of the key issues around this, as shown on the left-hand side of the screen, human factors, complacency, and so on, and such like. And you come through to issues on training and building use and security. And we'll address a couple of these as we actually go along. This particular thing I thought was absolutely fantastic. I've got no link at all with A&E fire training, but when I came across this particular application that they've developed a mobile portable fire training facility. It's like a smoke room, etc. You can do fire extinguisher training, you can do means of escape and evacuation and such like, and use this as a training module that you can actually take to people rather than having, for example, a facility or resource where they come to you for a particular type of training requirement that they have. I thought this was a brilliant piece of innovation in developing awareness and training. Building use. I'm sure we're all quite familiar with the Internet of Things, or the Internet for Things, depending on whether you're buying or selling, I think, really. And yes, we've had Internet-enabled systems in industrial and commercial operations for some considerable time now. But of course, things develop, and on the right-hand side, there is a graphic there showing what it could look like in the home. Some people may have got internet-enabled devices at home, certainly control their central heating and such like. For a fire safety perspective, that's quite interesting. I suppose systems at home could tell you who is at the front door in terms of CCTV and doorbell cameras and such like. Or it could tell you what the settings are for temperature of rooms or hot water and so on. But it's an interesting concept here to put your trust in being able to change parameters on things with fire safety implications in the home when you're not actually there. You can do it remotely. It reminds me, there's a brilliant television in the UK, certainly a television, not commercial, but one of these information films run at the moment on fire safety in the home, and that really is really quite an eye-opener, quite a good reminder about fire precautions and how to make sure that even in the house you don't put yourself at risk or your family as well. Moving on to the second one, having a look at professional impact. What are the factors affecting IOSH and other professional affiliations? Well, in the fire risk management group, we have issues around research and development and things that we do, and the links with people on the academic scene, those also who work in fire science and fire engineering, and also operational firefighters as well. We hope you'll keep following the fire risk management group, and hopefully we'll keep following you, because we do encourage feedback from people. We do encourage to hear from them and to find out what their requirements are, as it were, for documentation and information and such like. So it's absolutely vital that we have, as we do in IOSH, professional affiliations with these people to keep the interest going. So awareness. There's a group of students here. This photograph's taken at Lancaster University on a MSc course, who are learning, converting the theory they've learned into practice in terms of fire safety and fire awareness. But we have a role, each of us, we have a role in making sure that people we come across are made aware of fire risks, whether it's at work or at home or in society or wherever we are at the time. So this is a principle, this is really important, and we need to make sure that we keep up to date ourselves, for example, as we do with CPD, and keep our awareness very much alive so you can pass the message on to other people. Next, we're going to look at emerging technology in terms of topics such as climate change and natural events. The news at the moment is dominated, I think, worldwide by one particular event, but until recently, we've been hearing about climate change issues, and for example, there's a terrible photograph of wildfires which are occurring, but we've been hearing about it most weeks and looking at what the change on these natural events could actually that be and how it would impact the world in terms of fire safety. Looking at aspect and impact, how do these emerging technologies affect us and such like? Well, in my opinion, above all, there is almost an insatiable demand for more energy and a thirst for more electricity. Electrical power seems to be the thing. People are demanding more and more electrical power to run systems. There are issues with long distance electrical power interconnectors between, simply not just between countries, but also between continents at the moment, to try and get electrical power distributed to where it's actually needed. There are issues with renewables and solar energy, heat pumps, wind power. We'll look at some of these in a moment, hydrogen fuel and biomass, for example, but also lithium metal hydride, lithium batteries, battery banks, and flywheel storage. These are issues which a few years ago might have been fantastic, as it were, and people would be thinking how magic it would be to be able to take battery power or portable power with you to many places, and that's essentially what is happening now. It's a tremendous change. Wind power. Some photographs here of events, should we say, with onshore and offshore wind generation, where you have a turbine with a set of blades, as it were, driving a generator, generally certainly offshore, at the top of the mast, try and keep the electrics away from the salty stuff at the bottom. It's thought that a large number of these things, these fires that occur in wind turbines, are not actually reported. DNV have actually reported on this particular fact. And on failures, it's said at the moment about 19% of failures are due to blade failure. Electrical is down at 15 and structural down at 10. So electrical issues are pretty substantial in the operation of wind turbines of this particular sort. The next one is biomass power. This is one of the wall boards which I have produced over the years, and this one deals with safe storage of biomass fuels, etc. As we have done with all the presentations in this series, this actual presentation and the separate document, which are the presenter's notes, will be put on the portal. So if there are any points you want to check, or details or data, or to use any of the information in internal training, toolbox talks, etc., it will be there. I'll also put the wall boards there as well, which can be used for certainly for toolbox talks, or reminding people about the key facts around a particular hazard issue. So here we are, biomass power and safe storage. There's a problem, well, not a problem, there's a challenge here, because there are many hazards which are safety and health related as well, from storage of wood pellet and wood chip. And some of them include things like exposure to toxic materials like carbon monoxide from the disassociation of the wood. So what are the key hazards? Well, primarily issues identified from about 2009 onwards. So wood pellets, wood chip, the two little images in the center there, and you can get systems which run on a sort of wood flour. You can get generation of carbon monoxide, dioxide, methane, etc. And you get finely divided and spontaneous combustion if materials are not stored properly. The two different types of storage, on the right-hand side is a hopper, principally used for pellets. On the left, lower left there, is an underground bunker or vault, which is principally for wood chip. Wood pellets are not tolerant to damp or moisture or whatever, so you have to keep those as dry as possible, whereas wood chip is a bit more tolerant. And for delivery, the systems for wood chip underground, it's usually from a tipper truck directly down through the grill there into the underground storage. If it's wood pellet, then it'll be blow loaded. It'll be blown from a tanker-like truck into the big hopper glass fiber vessel on the right-hand side. This actually causes a bit of an issue because when you displace the air in the storage vessel, it usually is quite dusty. So you have to make sure you're venting to a safe place. Otherwise, you'll get a problem shown on that slide. And this problem basically is the buildup of dust. In these particular slides, this is actually a plant room. This is where the wood-fired boiler system is, and you can see the dust is so thick on the floor, you can leave footprints quite readily. The center photograph has electric motor there for a drive unit, covered with a fairly thick amount of dust on the top. And obviously on the right-hand side, we have sort of EX protected electrical apparatus, which is absolutely necessary in this sort of environment. There are implications with other regulations, such as dangerous substance exposure of atmosphere regs, because dust of this type is covered by the regs, so separate assessments need to be undertaken. But here there are significant issues in terms of fire safety and fire precautions in this particular topic area. Another wallboard we've done on dust, as it happens, showing also the safety and occupational health hazards. And there are respiratory and dermatological ones because they're the health hazards, but the fire and explosion one is pretty substantial, as well as slips, trips and falls. Dust is a dry lubricant on smooth flooring and surfaces. But there's also the electrical hazards. On that previous slide, you saw the ventilation grill on the end of the motor is starting to get clogged by dust. That'll cause it to eventually overheat, with the potential of starting a fire. It also affects mechanical and electrical machinery in terms of its operation. And if the dust gets in through lubricating oil or greases or whatever into bearings, then you'll get premature failure of machinery, which is not at all what you want really. So avoiding dust is a real requirement. Extending from biomass into another one of the new technologies is waste wood into power. Now, this is an interesting fire safety challenge that's coming up now, because here you can see there's a large granulating machine with an elevator, and there's also one in the background as well. And this basically takes old timber or unused timber. It can be timber from construction sites or demolition or waste. Deep breath. It can also be ground up kitchen units and things recycled and repurposed wood from all sorts of origins. And basically that goes into a gasifier which pyrolyzes it, such as the photograph top right. Below that is a steam turbine, quite simply, and a generator. This is the generator end of it all, where power is generated. Steam is still a great material, even in the 21st century for driving things like ships, submarines and such like, but also driving industrial plant. The power technology here, you can see there's another elevator and a great pile of raw material, which then goes into the pyrolyzer. This is normally shifted around with a bucket, hydraulic one on 4 wheels. But when that works, you can see in the bottom photograph, tremendous amounts of light material like dust can be generated. You have to be extremely careful in the storage silo on the right to make sure that, for example, overhead lighting doesn't cause hot spots or spontaneous combustion. And a raw material pile of this type is inevitably monitored by CCTV, looking simply for hot spots in the fuel source or the feedstock. Finally, the one in this particular area is another waste management issue, as it were. with what's called MBT, mechanical and biological treatment. This particular facility used to have a fire a week at one stage from all sorts of issues, and the hopper in the middle shows a load of discarded lithium batteries from life rafts. These are things that are used offshore, which is bad enough in itself, but when you find that people are discarding LPG cylinders and such like in their domestic waste, as well as lithium batteries from life rafts, it is a recipe for a great deal of concern, at least. So again, think of the fire safety implications of this and how you can actually address it. And it's usually, as you can see from the photographs left and right, and also the photograph on the left, you can see a red fire hose by drenching the whole thing in vast amounts of water to cool it down. I said at the beginning about hydrogen technology. This is interesting. Hydrogen could be a great fuel source for heating, power, and transport. It's a clean alternative to methane. It's the most abundant chemical element that we have in the universe, about 75%. Also, the blue sky moment here is thinking about, yes, how are we actually going to get the hydrogen to where we need it? Are we going to pipe it through the mains? And I'm just thinking here of the domestic situation. Is there going to be a changeover day when all the gas central heating boilers, hot water heaters, cookers, stoves and things are going to change from natural gas to hydrogen? I think that's probably unlikely. Are we going to use transportable gas cylinders like you do for example, LPG in remote rural areas? That could be extremely expensive. Or are we going to have home-sized hydrogen generators, for example, working on electrolysis? Well, that certainly is a possibility. Sometimes when you see this material burning, the flame is actually tinted a more yellowy color to distinguish it from LPG. From natural gas like methane. And also people use different terms now. It says there about blue hydrogen and green. Well, there are actually 4 colors now of hydrogen, which indicates where it came from. Green hydrogen is the name given to the gas produced from renewable technologies like wind and solar. The blue one there is also from methane, and there is a grey from industrial processes, and also a sort of turquoise coloured hydrogen, as it's known, from methane pyrolysis. There's quite a lot of things going forward into this form of technology. So batteries, well, we'd have to get onto this, wouldn't we? Lithium-ion, lithium metal hydride, it's something which Fire Risk Management Group has been looking into for a while now and has actually reported and written on. The photograph, the large one at the bottom there, shows a laptop computer with a rather ill-fitting case. And this does happen, it still happens today. It used to happen often with BlackBerry smartphones, as it were, where the battery would bulge and then the back would fall off the case. And if that's the case, sorry, a terrible pun there. If that happens, if the cells swell, replace them immediately, they are certainly at risk. And the image on the right is a sort of compilation showing a laptop fire in an office. Top right is a development which is extremely good on fire blankets for battery pack storage and such like, if they catch fire. However, the fire precautions for small lithium battery fires are quite significant, really, and there are probably 4 options currently available. So if a laptop or smartphone catches fire, you could do nothing. Not the best idea, I suppose, really, but you could do nothing but get the people out. Whatever you do, get the people out. You can address the fire with copious amounts of water or water immersion or smothering with a fire blanket. But I'm very grateful to Michelle, actually, for pointing out to me earlier about lithium extinguishers, this LithX type extinguisher, which uses AVD, which is an aqueous vermiculite dispersion, as it says on the outside of the extinguisher, to deal with lithium and also magnesium type fires. This forms a sort of skin, a material over the top to try and exclude oxygen if it possibly can. Anything in these presentations where it's underlined in blue is hyperlinked to a source of further information. So if you do manage to download the presentation and you go into it later, and you click on these hyperlinks, it'll take you to more information on the subject. One of the things which I found absolutely fascinating are robotics in fire prevention. And here's Spot the dog. So the future is here, as it says, with fire prevention, plant and equipment inspection, measuring and monitoring and safety tasks in any condition. He's a robot, and he can be pre-programmed to do particular things, used in industry to go around and monitor valve positions and read dials. He's got a camera. There's all sorts of fantastic things. Climb stairs quite easily. And there are a couple of things. Spot is built by Boston Dynamics. Costs about £30,000, I think, at the moment, although I'm sure the price might be negotiable. And of course, there are other copies. His imposters may speak to you with a Chinese accent. So Spot is on YouTube, and the physicists and engineers who developed him, together with the IT guys, quite a geeky thing. You can get racing versions now. I'm not sure if they're commercially available. I don't think they are, but they've just extended the technology fantastically into almost like whippet racing with robots. Right, so new products, section 4. You're probably thinking, oh God, he's going to talk about electric vehicles. Well, I can't afford an electric vehicle. I don't need one. I don't need to buy one or whatever. How relevant is this to me? Well, all I can say is in a corporate role I had a while ago, we were looking after 6-story and 3-story office blocks, both of which had underground or basement car parking. And one in particular, suddenly one day, 3 electric charging points arrived. This hadn't crossed the safety desk. Nobody knew this was arriving, and contractors arrived and installed them. Because apparently electric-powered vehicles were then available for senior managers on the company car list. So you might be looking after safety on an industrial site or an office block or whatever, and suddenly things change, and you really need to think about how you're going to deal with the fire precautions around electric vehicle charging. Just to keep you exactly up to date, here's the view from the cockpit window of the Felicity Ace, which was a ship that was on fire and eventually went down just off the Azores, carrying a very large cargo of Volkswagen Group products, principally Bentley, Lamborghini, and such like, for export. And the thought that's now going round is, was it the result of a fire in one of the hybrid vehicles that was actually on board the ship? Normally, when you're transporting cars, it's fairly benign. There's not many issues that are going to cause a fire other than the normal marine ones, but this could be a significant finding. So electric vehicles, 4 main types: 2-wheel and 4, commercial goods, domestic, and for military applications, as well as social and recreational. So the top 2 photographs there show a sort of light hybrid system. It's actually a Mercedes system, where you have an electric motor supplementing the turbocharged petrol engine with a second battery system in the boot to give a bit more oomph. Plug-in hybrids, all electric vehicles and such like, and electric motorcycles. The one on the left is it's called the Firefly. It's made in China, now being bought by the MOD in the UK for battlefield troops to whiz around with. It's quite remarkable, really. But if you prefer your motorcycle to drive on the left-hand side of the road, then there's the Triumph T1, which is a famous British name, now electric. The performance of these things is substantial, should we say. And just to keep you up to date, to the end of January this year, there are over 675,000 plug-in electric vehicles on the roads in the UK. What are the fire risks and insurance sector's view about it? Well, there's a copy of the Tesla book there in the handout information for you. It's worth a read, it's quite interesting. Remember that these fires with this sort of technology are chemical fires, really. No oxygen is required. We've also put a link into a piece of television, which was done by Guy Martin, Isle of Man TT rider and such like, who's done a series of extraordinary things on the television. And he tries to put out a fire in an electric vehicle. The YouTube film has to be watched. It really is quite interesting. It's an October 2017 paper there, which says it all in the title. But I'm sure there are many others, and maybe it's something that we might, in the Fire Risk Management Group, look into at some stage as well. The other hazards are euphemistically called driver risk management. In other words, the insurance sector is worried about the power and performance of these vehicles, and people with very little experience of high performance motoring are suddenly able to buy them and put themselves at tremendous risk. The performance is massive. Finally, there's an interesting point here that there's only 103.5 million lines of code in a Boeing 787, whereas your average Tesla type vehicle is 150 million lines of computer code, which is quite astonishing. And a report, in fact, in the Times this last week is saying that in terms of reliability, you have petrol, diesel, and electric. Electric is the least reliable, not from a mechanical issue, there's fewer mechanical parts to move, but from a software issue. It's still an issue that needs to be looked at. So electric vehicles, what are the fire safety concerns? If there are people involved, it cannot be stressed any further than get them out. If you're in the car, beside the car, put distance between you and the thing that's on fire. There is tremendous transmitted heat from these things. There are issues for car parks, especially multi-stories, which of course come under approved document B. And we've had a question about that in relation to the Designing the Fire Safety webinar that was presented very recently. Remote handling solutions, that could be the only way out of this, really. And there's a solution on the next slide. Here's the Danish one. So vehicle fires of this type, a big red box, basically. And here it piggybacks by hydraulic crane onto the back of a large and substantial road vehicle. You just load the thing in there, you sort of seal it up and drag it off, and then deal with it all later. Fire blankets for electric vehicles and also internal combustion engine ones are now available. And from a fire safety perspective and fire precautions, I think this is fantastic. This really is a very, very clever solution. It's obviously large enough to cover over a vehicle. And for example, in the photograph on the right, used by ferry operators as well, who may be experiencing fires with vehicles of any type on car decks on ferries. Electric vehicle recharging. The top photograph there shows me a BMW i3 being charged up at a Shell recharge station. I think it's absolutely great. Interestingly, there's a foam extinguisher behind it. Not probably the most appropriate one for the job, but there we are. And below there, there's also another more modern charging facility run by Shell. The map on the right shows where their facilities are in the UK, for example, at the moment. But I expect that will be changing quite significantly as the systems are expanded. Photovoltaic. It's interesting trying to get details on this for domestic type and industrial installations. I found some data from Germany, but only up to 2012. And there you can see the causation which they've put in. Typically, things like components, DC isolators, and such like are are the ones that fail. BRE has done some more analysis of fires up to 2012, but it'd be interesting now, 10 years on, to find out what root causes are coming through in terms of photovoltaic system fires. On the right-hand side, apart from not attributable there, poor installation is cited as one of the significant issues. Michelle also gave me a link to this piece of technology which has been developed in Australia. And again, there's a YouTube film which is well worth watching. So how do you actually cut off electrical power from a photovoltaic device? You can't simply turn it off. You could try and cover it with a blanket, but it might not actually work. So this material has actually been developed brilliantly, I think. It's a polymer. It's from a pressurized container, it's blown out with nitrogen, and it is a fire extinguisher-like product. You can see a firefighter there doing a test, covering up a photovoltaic array of panels, and it's a black gooey-like substance which goes over and seals the surface, cuts down light. And if you watch the films of this, then the power meter, which is top left there, just cuts off within seconds. Fantastic safety innovation, that. And there's a guy out in the outback, I think, with his system trying to cut that down as well. Hydrogen-powered technology for vehicles is with us. So there's the Toyota Yaris, and they've developed a 6-cylinder engine, top right, to power that along as well, quite substantially. And up in the north west of England, here we've got hydrogen-powered trains. The slight, I use the word carefully, amusement on this particular thing is you need a carriage the size of one of the passenger carriages to contain the hydrogen technology equipment to get the train to trundle along the track. So hydrogen-powered technology for vehicles is with us. Shell has certainly got 50 globally and 5 in the UK, although that number could be increasing significantly. You can see on this particular photograph here, there's actually a conventional fuel station on the right-hand side and the hydrogen station on the left. It's powered by electrolysis, basically. There's an electrolysis cell in there, which produces hydrogen, which then goes into your hydrogen-powered vehicle. Looking at other forms of transport, and you probably say, well, why is he talking about cruise ships? I'm not likely to go on one or whatever. Well, you may do, you may be fortunate enough to. But if you think, if you're the guy who's the safety manager or an advisor, you're working with people who run ports and docking facilities, just think of the fire safety challenges in this sort of thing. You can get hybrid power, LNG, liquefied natural gas, and solar driving ships of this size now. Certainly some have got fuel cell technology for hydrogen. Certainly some make synthetic diesel from fish, apparently. I think that's quite ironic. But now they're using shore power, which people in the leisure industry have used for years in boat marinas and such like. You connect up to shore power rather than using the generators aboard the ship to generate shipboard supply whilst it's tied up alongside in port. And they're also using battery power for sensitive environments, for example, Antarctica and Galapagos Islands and such like. So these are very, very, very challenging design for fire safety risk assessments for us all. In one of the earlier presentations, we talked about the photograph top right. Unfortunately, a guy put a head torch in his pocket with his car keys. It shorted out and burned his leg. And some of these devices, for example, on the left, are very, very common these days. They're used to supplement typically mobile phones or laptops, which are low on power. So it's a pocket-sized portable thing. The photographs in the center with the Airstream caravan and bottom right, this is taking it to another level. And basically you're using photovoltaic to charge up the box there, which looks like a picnic cool box, is in fact a lithium battery pack. You can get 3 and 4 kilowatt versions of these things, which could run your campsite in the outback or the woods for a few days. Significant fire safety challenge, I think, in running that. It works out about $1,000 per kilowatt, so $3,000 to $4,000 for the power system to run out in areas which are off the grid, as they say. So fire safety management systems and the methods that impact control on fire safety. We're quite familiar with these policies, processes, and such like. Fire risk management groups works all the time really on keeping an eye on these systems and what we need to do to make sure we keep up to date with issues there. For example, mentioning about fire risk assessments and mentoring and CPD and such like. Number 6 on our organogram, on our mind map at the beginning, were legal issues. And our colleague John Field, for example, does an excellent review annually. It might even be a bit more frequent than that in the future, but certainly annually, looking at, for example, recently the Fire Safety Act and building safety, and working on things like golden threads and such like, with guidance specific and targeted for industry and operators. So we hope to keep you up to date with things like this and make sure that you've got all the right information that you need. One of these developments, this is something that I've put together to illustrate a point. This is the golden thread type thing from the new fire safety legislation. And the key points to mention are the boxes with red borders. So starting with the original design and working through gateways, gateway 1, 2, and 3, and the hard stop, for example, at gateway 2, you will not get past that to allow you to construct unless all the issues in gateway 2 are complete, or gateway 1 and 2. And then you won't get past gateway 3, which is the practical completion gateway, to actually occupy, to allow people into buildings, unless all these things have been completed. And then you come through to the top event, as it were, on resident safety at the end. And that's one of the developments in the process. Fire prevention. Well, we've talked also around issues like this and designing for fire safety and such like, and materials. I don't want to say a great deal on things like this, but we're all familiar, I'm sure, with modern methods of construction and selection of materials and standards and testing. And our colleague Michael Woods has done an excellent presentation on this as previously. And a couple of the slides we use there, for example, in designing for fire safety and construction, are here: timber buildings, off-site manufacturing and such like on the back of the low loader here, reducing fire risk on site when things are being constructed. Fire precautions, things that are changing in that area. As you can see on the list here, one of the interesting things are things like these condensed aerosol fire suppression systems. There are 3 or so trade names at the top on the first point on the slide. I was quite interested to read about these things. They're being used, for example, with special hazard applications, such as the generator facility in a wind turbine, and electrical cabinets and vehicle engines for putting out fires. It's a very old idea, as it were. It's a fire extinguisher bomb that it was called originally in the 1800s, when they were developed. Some of them included materials like carbon tetrachloride, but that caused a particular hazard of its own. Some of these new ones are things like potassium nitrate, and the idea is it forms a device, it is thrown or deployed at the fire and disrupts, as in the tetrahedron there, the advance from the fire triangle, the chain reaction in the fire itself to suppress it. firefighting drones and robots. The one on the right-hand side is based on a flying taxi of all things. It's a Chinese innovation and looks particularly interesting. And you can see the size of the thing. It's got scale because there's a building in the background. And also robot technology, for example, on the right there, developed in Malaysia and also in India. In the Netherlands, they've taken a very interesting approach here because they have very large rail yards and marshalling yards, and unfortunately do have some fires in trains. So their technology on the left, for example, is like an IED robot, which is Caterpillar tracks, and it goes off, takes a supply of firefighting media with it, and can really get in at the heart of the fire to put it out. On the right-hand side, it's essentially a standoff device. It's a massive pump in a firefighting appliance, which can project a jet of water some considerable distance onto the fire in the train. So interesting approaches there from the Netherlands. But this seems to, I use the word beat the ball actually, it's returning to the climate change challenge that we talked about a few slides ago, and fighting forest fires. And here in the northwest of England, I would think this might cause mayhem over Saddleworth Moor or Pendle Hill or whatever, where we've had tragic fires over the last couple of summers. Because if this modified 747 is dispersing its firefighting media like this in the area of the final approach to Manchester Airport, I think incoming EasyJets might be a bit worried about that. But it's a tremendous achievement, isn't it? It's a fantastic, fantastic solution to a problem which seems to be with us now. Fire investigation, that's an interesting one. What are the developments in this? Well, all I can say really is that things are actually coming around full circle. We are around our mind map now, and we're looking at issues with drones. The fire investigation webinar we showed a photograph of a drone being used to photograph a scene from above at the University of Bristol. There are issues on detection and instrumental techniques and IT and electronics and security and such like. But one of them also is on professional standards and making training opportunities and such like better. There's a code of practice has now come out in the second edition in April 2021, and that's supported, for example, by the Institution of Fire Engineers. So it deals with standards of good professional practice for fire and explosion investigators in the UK. So what are the conclusions? What can I draw to your attention, as it were, at the conclusion of all this? Well, supporting people professionally, yes, that's pretty much the top one. That's the work our risk management group is hopefully doing. And I am also thinking that through the work IOSH does in other fields of occupational safety and health, and also the other professional institutions, whether it's science, technology, engineering, or fire engineering, or whatever, we must keep on with this. We must keep supporting people, enhancing their professional interest, influence, and impact through greater awareness and generating better training outcomes. I put being mindful of efficient building use and building security, and thinking also of care about reliance on the Internet of Things, or the Internet for Things, in terms of fire safety. What happens if the Internet goes down? There are issues with wireless fire alarms and smart homes and such like, and now Internet-enabled devices. Be aware of emerging technologies. I've said here that some bring a fire safety sting in the tail, like electric vehicles and such like, biomass and dust issues. So whilst you may have an attractive solution to a particular issue, there will be challenges in fire safety in actually managing that particular change in technology. And be aware that promises of great convenience and super cheaper performance do not necessarily mean safer outcomes. And returning to our old friends here, for example, lithium-ion batteries. Future in fire safety may well be with machines and drones and robots. I think that's probably going to affect us all in every walk of life. Don't expect changes in legislation and guidance to be fast moving. It's following the tragedy in Grenfell Tower. We've got new legislation and guidance coming along, but it's taking time to get there. So it won't give instant and efficient and effective returns, but we will get there. And we'll look also at benefits in modern methods of construction and sprinkler technology, enhancing materials and working on integrating fire safety in the design of safe solutions in the built environment. Thank you all very much indeed for watching and listening today, and I'll hand you back now to Neil.
Thanks, Ian.
No,
it's fine. I know it's all a bit lastminute.com my end, but no, it's me leading the Q&A, which we have had. We've had 14 just pop through. A mixed bag, which is great, and I think very reflective of the information that you've just given there. So I think we're going to start going back to our good old favourites of the batteries. What makes you're smiling? Sorry, my questions.
So you.
Another one's come through. Could you explain the differences between the lithium-ion and lithium batteries, please?
Differences, that's an interesting question. Maybe I have to read what's actually the person asking the question has written.
Yeah, no, that's absolutely fine.
One of the principal factors in this is the high amount of energy that's available, and also it's greater long life. It's about storage capability and such like. They really are powerful little power packs, as it were. There's even an idea at the moment, again, has been widely reported, about aircraft being battery powered, and flights have occurred with light aircraft. There are ideas, there's a reference also in the presentation there to some work done by NASA in the US about having battery powered systems in hopefully what we'll be pushing towards commercial operation. But these are powered by things which are probably the size of an AA battery. Just there's a huge number of them. So yes, it's lithium-ion and lithium metal hydride batteries are very, very interesting and useful power technology. The problem is that you have to be extremely careful in how they are charged up and such like to give reliable performance. But as you pointed out, I was smiling earlier because we have actually reported on this in one particular issue with instances where batteries are being recycled.
That's great. Thanks, Ian. I know we can go into a bit more detail when we respond to the Q&As after the webinar. We've had one come in around wind turbines. Is it safe to investigate wind turbines after fire incidences? Means that how we'll approach or to go inside the wind turbine?
Yeah, that's a very good question. I think you would want to try and do some investigation and some root cause analysis. I think what you'd probably start with would be the information and the data that you can get from the device, which is often monitored remotely by some control station somewhere, even in the DNO or whatever, or the power company's head office. You'd want to try and work out how an event has occurred. You might be looking at voltage and power and all these sorts of things. if you can then get there and use a drone, for example, on a pretty calm day anyway, you might be able to get some real footage of the debris that you can see and the condition, or other witness statements from people. Getting inside the tower, well, that's an interesting thing. Yes, these things are generally hollow, and there is a ladder up the middle, and you clip onto a fall arrest system and go for an extremely long climb from the bottom up to the top. I think you'd have to be extremely cautious and do your risk assessment properly to get up there to investigate it. But yes, you can certainly use other technology to help you come to some sort of root cause analysis. Yeah.
Thanks, Ian. I'm just looking at one that's come through around counterbalance fork trucks. And again, in relation to lithium-ion batteries, would the AVD be good enough for the larger size counterbalance trucks with lithium-ion batteries?
I'm going to say immediately, speak to the supplier of AVD extinguishers. The one that was shown on the slide there is a relatively small, I'm not going to use the word domestic, but you could use it at home. It's a relatively small one, probably typically found in offices. You can get substantially larger ones, and larger extinguishers. And if that's the case, then I'm sure the supplier of the equipment would be able to advise on that. I've not actually personally seen any testing done. We did talk about the Guy Martin YouTube film, which is particularly interesting, and I would imagine that the lift truck will have a fairly big power supply on it. So you might need two of the large AVD extinguishers, but speak to the manufacturers and see if they've supplied in this particular area. What I would actually say is some motor vehicle manufacturers, of course, historically have provided fire extinguishers in vehicles on the accessory list. You can buy them and fit them and everything else. To the best of my knowledge, nobody is specifying an AVD extinguisher at the moment if you had a lithium battery car. But the way these things develop, I think the fire will be quite quick acting. And as we said on the slide, the thing to do is to get people out, get them away from the risk as quickly as you possibly can.
Thanks, Ian. I've just noticed the time, and we are rapidly approaching the half past the hour point. We have 19 questions still open, but yeah, they are still coming in. To everybody that has sent in a question, please be aware that we will respond to these. We have a collection of them at the end, and we will be publishing them on our page. Now, with that, I'm going to end the Q&A session, and I'm going to hand you over to Neil Venser, Chair of the Fire Risk Management Group, for his final message.
Just before we go, Michelle, can I just add that the Q&A, the questions which people have submitted, we've replied to in writing, they're actually being compiled into one big book as well. So there's quite a lot of information which people have asked about, and we're really grateful for that. It's given us a lot of ideas and such like. So we will produce a big blue book on questions and answers, and it's keyworded as well. So if there's an issue which you want to try and find out something on, then hopefully we've been asked the question before, and we will address it.
Okay.
So thank you very much. Back to Neil.
Yeah. Okay, thank you for that, Ian. And can I just say, actually, as this is the last of this series of 6, I would actually like to take this opportunity to not only thank Ian for presenting this very interesting, I think really thought-provoking session, but also to thank all of the other members of the committee who have participated in these webinars and actually made them so successful. So I'd like to say a big thank you to Ian, to Anne, to Alan, to Gary, and to Michael for taking on the role of those presenters. I'd also like to thank John Field, who presented the associated webinar session on fire legislation. And as Ian said, hopefully we're going to encourage this to become a regular thing, and we'll hopefully keep you up to speed with what's happening. A reminder, these are all available as recordings via the IOSH website. I also need to thank a huge thanks to Michelle, my vice chair, who has actually helped me to share the chair responsibilities throughout these series of webinars. Thanks, Michelle. It's been great fun working with you and indeed on these as well.
And everybody's my daughter singing in the background, so I can see all the comments coming in. Thank you very much. She is 3 years old and does join us with all our webinars. So thank you for those comments.
Our youngest contributor.
Yeah, exactly. And what I must also thank actually is the people behind this are actually Dimple and Ben from IOSH. Thank you to those guys, because without them, we really wouldn't have actually had a series of webinars at all to present to you. So I think, as Ian has said and Michelle's both said, actually, we're now taking a short break, probably a couple of months, but we will then be back from you, maybe leading actually with some new webinars and presentations based upon your questions. So it goes to show the importance of actually you asking questions to us, because it means that we can actually make our way forward and give you what you want as well. So keep an eye on the social media. If you're not on LinkedIn, look for the Fire Safety Management Group, which you'll find on there, and that will keep going and we'll regularly update you on there. But if you're not a member of the group so far, maybe actually consider joining the IOSH Fire Risk Management Group. The details of that, again, are on the website. So finally, this has been a very, very successful webinar from our point of view. And certainly looking at some of the comments being received today, clearly you've enjoyed them as well. So thank you for attending. For those of you who've made it through all 6, well done. I'd love to give you each a medal, but well done. And hopefully you'll look forward and join us for our future events. So a big thank you and goodbye from me.